synthetic division and all that in a little bit, well, tomorrow. Synthetic division is going to allow us to factor. It's going to allow us to factor these polynomials real fast. And that's what's nice about synthetic. But within 6.6, 6.7, part of 6.8, it's all kind of blends together about writing polynomials, doing all the other stuff, factoring them all out, all these different rules that you can have. But the basic idea is division. So we still use long division. We use polynomial long division in Algebra 2, but we also use it again in pre-calc, actually at this same time, go figure, to find what are called slant asymptotes. Yes, you can have horizontal asymptotes, vertical asymptotes, or a slant asymptote. I know, it's crazy. Long division allows you to find it. So long division was this, and some of you may or may not remember it.
I never worked with numbers that big.
So I want to look at how in the world do you use long division? What is the process that you're using? Because we're going to use long division with polynomials next. Somebody just said, what was it? Does McDonald's sell cheeseburgers? Never.
Serve or sell.
Isn't it the same thing?
No. Yeah, it's serve.
But isn't serve and sell?
No.
Is it-
I could sell you
it, but not.
but that doesn't mean I'm going to give it to you. Like, personal. Yeah.
Oh, I know, but I'm
He's asking for the acronym.
We're looking at the letter S as well.
Yeah. Yes, serve, man.
But we're talking about serve and sell.
It's serve. Which is it?
All I'm saying is that I've never heard that before. Anyway, what's going on here is we're going to figure out. Yes, those are numbers. 4,730,542 divided by 11.
How many times did you
Nope.
47? 4.
Correct. And where do you put the 4?
Right above the 7.
Right above the 7. Now, the reason that we're putting it above the 7 is because we're using a placeholder because 4 times 11 gives you 44, so it works it out. Oh, no, silly boy. We don't use calculators. Then what? Subtract, good. You get a 3. Bring down the next one.
I remember this from way back when. 3.
3, good. 3 times 11.
33.
Subtract it. Bring down the 0.
Yep. So you put a 0 in.
Deshante, you okay? Your eyes are like. All right, remember, after I've gone through that, 33 to minus 33 is 0. I bring down the next value. The next value just so happened to be a 0. How many times does 11 go to 0? 0. 0 times 11 is?
0.
0 minus 0 is?
0.
Bring down the 5. Does 11 go into 5?
No.
So what do I put?
0.
0. Bring down the 4. 11 goes into 54 how many times?
4 times.
4 times.
This is easy.
And drop, what was the last digit? We wrote it so long ago.
2.
Now 11 goes into 102 how many times?
9 times.
9 times.
9.
9 times, good.
Yep. 9. Remainder 3.
Now I heard you say remainder 3. You guys, when we did this, did you know what the remainder actually stood for?
Fraction.
Good, very good. It's a fraction amount. So it's not just remainder 3, but we will write it as a fraction. We'll write it as 3/11ths. So it's 430,049 and 3/11ths.
How much space on the sheet?
Which is a little bit less than 0.3.
Right there.
That made the world so much clearer for me. That helped me actually understand the problem. Thank you, Mr.
What, the writing?
That line right there.
Oh. All right. Now, the idea of doing it this way is so that you guys remember the process what you were saying, does McDonald's serve
Yeah, there you go.
cheeseburgers?
Do they?
I don't know. Do they come out to your table and bring you your food?
They come to the counter, so it's not serving.
So it's self-serve.
Is it? No.
Is it?
For the drinks.
There's this really nice
They
McDonald's
serve you the
like.
cup and you self-serve yourself.
Now, have you ever been to McDonald's and say, "Oh, we'll bring it out to you when it's done"? Maybe they're making more cheeseburgers.
Oh, there you go.
There's this little Irish McDonald's. It's so.
Or they had microwave the ones from 4 hours ago. Anyway, let's do this then.
Welcome to McDonald's. How would you like
We're gonna
to-
go right to polynomial. Now, one thing I want to show you guys as you're writing these things out, don't write them down the way the book writes it. Write it down in that long form of division like you would normally. 2x cubed minus 7x squared minus 17x minus 3 divided by 2x plus 3. Now, when I have a third degree polynomial, how many terms should that have? You're about 10 minutes. 4. Remember, you will always have plus 1 to your degree for the number of terms in the sequence. So that means sometimes you might have to have a placeholder. You could have placeholders in underneath the division or a placeholder on the outside as well. Whatever your degree is, you have to make sure you have n plus 1 terms. So for example, if this was just 2x cubed minus 17x minus 3, I have to put a 0x squared in. Does that make sense? It's kind of the same idea when we did that synthetic substitution where we put a placeholder in. Same idea. Okay? So now, what's going to change a little bit different is going to be the following. How do I turn a 2x into a 2x cubed?
Cube it.
If I cubed it,
Square it.
I'd get 2x to the 4. I multiply it by x squared. Now, what I want you to think about is if I'm multiplying it by x squared, just take a guess underneath which one of these you would put it underneath. The x squared. You're always going to place it underneath whatever power you're multiplying by for your first step. That's just the generic rule. Okay. So I put it an x squared here. Whatever I have to multiply it by, I want to line it up with whatever power is below it. Whether it's x squared, x cubed, x, whatever. You just line it up. That's the generic rule. Okay? It's okay, Shuki.
She hit her head on the desk.
No one heard you on the wall.
Did you fall and hit your head?
She's got it.
She's actually fallen and she can't get up. She just doesn't know yet.
That's bad. So going back to division, when I put the number up on top, I have to multiply it. So if it was a 4, we'd multiply it by the 11, got 44, and we'd subtract. Now I'm multiplying polynomials. So I have to multiply the x squared to both parts here and get 2x cubed plus 3x squared. And now comes the part that you have to remember to do. A lot of you guys, when we did the division problem, oh no, that's pre-calc. Anyway, a lot of the pre-calc people, when they did the division problem, they forgot this subtract both parts. Put that subtraction symbol between each term, whether it's 2 terms, 3 terms, 4 terms, whatever it winds up being. That way you know you're subtracting each piece. So you get 2 minus 2, it's gone. Negative 7 minus 3 is?
Negative 10.
It's negative 10 x squared. And what do you think the next step is? Bring down the negative 17x, very good. And now you're asked the next question. How do you multiply, what do you multiply 2x by to turn it into a negative 10x squared?
5x.
Negative 5x.
Wait, is that how it always works? Like,
Yes, sir.
go older?
Yep. Yep. Multiply it over, you get negative 10x squared minus 15x. Subtract between the two. Negative 10 minus negative 10 goes away. I multiplied negative 5 times 2x, negative 5 times the 3. I have to distribute to both parts. How do I turn a 2x into a negative 10x squared? So what's negative 17 minus negative 15? Very good. And then I bring down the -3. Lastly, what do I multiply 2x by to turn into -2x? -1, very good. And when I subtract it all out, is there a remainder? No. Mr. Pope?
On the first part, you did the 2x cubed plus 3x squared. It was, you had the plus between the two terms, and then you subtracted that out, and then on the other one, you had...
Take a look at what I was multiplying my top by. See how the first one I had multiplied by x squared? When I distributed the x squared and I got 2x cubed plus 3x squared, the next one I had to multiply by -5x, so I got -10x squared minus 15x. That's how that's working itself through. You're keeping the sign that's up on top, distribute it to both terms on the outside. That's why we got those negatives there. Does that make sense?
Kind of, yeah.
Yes, ma'am.
Do you always use the first term, or is it which one has the highest?
Always use the first term.
So if it was 3 plus 2x, then we use 3.
Oh, I'm sorry. I thought you were talking about as you're eliminating. You always put it in descending order, and then go for first terms. Right. Now, what's nice about this is since this had a remainder of 0, that meant 2x plus 3 is a factored term of 2x cubed minus 7x squared minus 17x minus 3. So we basically factored that out and showed that it did work, which means that we knew that there was at least one 0. One 0 occurred at -3/2.
Where did you use that?
You'll see more of that when we do synthetic. Okay. Sir. Yeah, I don't know. You can point the guns away.
Sorry.
I'm sorry, they just,
You gotta
they just
set
pop
all
out
the
sometimes.
D's for.
What?
Let's try again. 2x to the 4th plus 3x cubed plus 5x minus 1. We're going to divide that by x squared minus 2x plus 2. So as you're noticing it when you're writing it down the first part, you've got 2x to the 4th, which means how many terms should you have? You should have 5 of them. So we have to, what do we have to put in there? 0x squared, good. So we wind up with 2x to the 4th, 3x cubed, 0x squared, 5x is 1. And we're going to go through the whole exact same process. What's that? Oh, it's okay. Yeah, a lot of people were saying that earlier today too. They kept drawing it and it looked like a square. It's not. So I need to turn x squared into a 2x to the 4th. What do I multiply it by? 2x squared. So which one am I going to put it above? I put it above the x squared. Very good. So I start with a 2x squared here. I have to distribute this to all 3 parts here. We'll get a 2x to the 4th minus a 4x cubed plus a 4x squared. How many terms am I subtracting? 3 of them. 2 minus 2, that goes away. 3 minus -4,
Negative 7.
7.
How is it 7?
3 minus -4, same change, opposite. Okay.
Keep the change.
0 minus 4.
-4.
Very good. And then bring down the 5.
One at the one.
We're going one at a time. Just like in long division, you just drop each consecutive value after you divide.
It's like this one digit.
Yep. Yep. In this case, it's next term. If that makes sense. Drop in the next term. So now what do you multiply x squared by to turn it into a 7x cubed? 7x. Is it positive or negative 7x?
Positive.
Positive 7x, very good. Multiply in, we have 7x cubed minus 14x squared plus 14x. 3 subtraction problems. What's that?
What'd you do for that part?
I wanted to turn the x squared into a 7. So I multiply it, or excuse me, x squared into 7x cubed. So I multiply it by 7x. And then I distribute through again. 7 minus 7, gone. That's good. Negative 4 minus negative 14, 10. 5 minus 14,
Negative 9.
and then I bring down the negative 1.
Multiply it by 5.
I have to multiply, I gotta turn x squared into 10x squared. Well, 5 times x is 5x, so
I assume there's a 2x squared.
then I multiply it by 10, distribute out the 10, we're gonna get 10x squared minus 20x plus 20. So 10 minus 10, that goes away. Negative 9 minus negative 20, 11, very good. And then negative 1 minus 20,
Negative 21.
minus 21. That's now a degree less than what I was dividing by, which means it's the leftover, which means it's a remainder, which means we write it as a fraction. Exactly. Yes, ma'am?
Wouldn't it be 19 because it's negative 1 minus negative 20?
Nope. Because then you're adding more negative. Negative 1 minus 20. Okay. So that's my leftover. Is the 11x positive or negative? And how do you know that?
Because
There's no negative in front of it. So I would write this as plus 11x minus 21 over x squared minus 2x plus 2. That's my fractional remainder. I get a rational remainder. Whatever the remainder is goes on top. Just like it was earlier when we had that 3 left over, we divided by 11. It was 3/11ths. Same idea. It works the exact same way.
Easy.
It takes a minute or two to go through it. That's about all it is. And the worst thing you guys are going to screw up is not knowing how to add. I know it's tough.
I forgot basic math when I came into honors.
Let's try them.
Like 2 plus 2, man. I couldn't do it.
I got that, but like the basic.
Oop, wrong one. It's fine. Yeah. This is one of those sections that if you're not careful when you're writing stuff down, it's very easy to read the wrong problem. So let's do the first one here. So we'll have 3x cubed plus 2x squared minus 5x plus 1. We're going to divide that by 3x plus 1. Oh, did you write down the wrong? Yeah, and that's just what I got done saying. You guys are going to write down the wrong parts. Happens a lot in this unit.
That's not good.
It isn't. because you don't know if you're doing it right. What do I multiply 3x by to turn it into a 3x cubed?
X cubed.
X squared. So which one am I going to put it over?
2x squared.
Very good. Multiply in. Oh, sorry, that's supposed to be an x squared. My bad. And now I subtract. That's gone. What's 2 minus 1?
1.
What do you have to multiply 3 by?
Fraction.
To turn it into
Fraction.
1.
Fraction.
Third.
So does that doesn't work?
1/3 x, obviously. So 3 times a third is 1. So we get 1x squared plus 1/3 x. Distributing to both parts. Welcome back.
That was an evil laugh.
So I get, hold on, no. You're going more negative. So you get negative 5 1/3. Now, does everybody agree that negative 5 1/3 is what as a mixed number? Wouldn't that be 16 over 3? Yeah, and this is the reason why I'll show you guys a little bit easier way to make this work. Go right away to a mixed number. You have negative 16 over 3x plus 1.
Improper fraction, not mixed number.
Yeah, thank you. Improper fraction, excuse me.
That was him who said that.
So now, this is where it gets really weird. I need to multiply the 3 by something to turn it into 16 over 3. What is it going to be?
16 over 9.
Good. Obviously, it would be negative.
Time out. What?
Think of it this way. 3 times something, I don't want to use x. 3 times something has to equal negative 16 over 3.
Yeah, right.
That something
Times 1.
is that. You can always set that up to figure out what fraction you have to multiply it by just saying, oh, I just got to multiply by the reciprocal and it'll work.
All right.
Math.
What the 1/3?
How do you undo multiplying by 3?
Right.
Isn't dividing by 3 the same thing as multiplying by a third?
Yeah, I guess.
That's where it comes from.
Do the
I feel like
reciprocal.
I'm winning.
Well, yeah, if you're in Hawaii, so
I am in Hawaii.
good work. So multiply everything by negative 16 over 9. And we get negative 16 over 3x. And then it was what? Plus 1? Or so it'd be minus 16 over 9. Subtract it out again. 1 minus negative 16 ninths is the same thing as saying 9 ninths plus 16 ninths.
25 nines.
There you go.
Which is 5.
And that's your fractional remainder.
Oh, gross.
That's gross, but it works.
It's got like square roots and everything. It's nice.
That's fine. It just winds up being a complex fraction. That's all.
Can you go back down this one?
Yeah, no problem.
Complex fractions.
What's the definition of
Fractional fraction. Like multiple fractions.
Like 25 over 9 over
We actually
9
do,
over
we
3.
have complex fractions. Okay.
Tara, this situation with Brandon just
You can go back up.
it's just something that happened.
What's that?
That's the
Okay.
one that like, I wore this.
Let's do another one. Do this one.
Yeah.
11
And then-
is Brandon.
And then you lose these two. Don't kill you.
Oh, it didn't.
And then you go extra and use parental.
No, that's not the thing that happens. Jose, have you accidentally kissed your friend before?
What's happening on your shirt?
You've never seen that movie?
Leave me alone.
And Ariel is trying to.
All right, let's take a look, see how you did. What do you multiply x squared by to turn it into x cubed? X. Distribute out, you get x cubed. 3x squared minus 1x. Subtract out, we get 2x squared plus 6x minus 3. We multiply x squared by to turn it into a 2x squared. Plus 2. Subtract it out, we get -1, and that's my remainder. So it's minus 1 over x squared plus 3x. Yes. Not so bad? Want another one, or are you okay? Section 2.6, we put it in here. There's 6.2. Wait. 6.5. What is this?
6.5.
Somebody broke this marker and I'm so upset.
When your life is turning blue, I don't know about that shoe, so don't worry. Be happy.
Is this homework?
Yeah, section 6.5, page 356. 16 to 26, evens. Don't forget placeholders if you need them. Okay.
You're such a nice guy.
Sometimes you might need placeholders on what you're dividing by. Like example on number 22.
What about it?
Stop that.
You'll notice on 22 it goes x squared plus 5. What do you need to have between the two of them?
You're not my dad.
You have 0x. Okay, so you can have placeholders on either the inside or the outside. Okay? You guys are so unbelievable. You've already used that joke once.
I know what
He just
it
started
is.
Are you guys all in the same classes that you or other champions? Or it's like the only time you're all together?
I have
I'm sorry. It's not too late to switch to third hour. Yeah.
Sam, you don't switch.
Why is that?